Hello and welcome to today's session. This is Jyoti Dodia and this is the 78th session of the Power Virtual User Group Technical Webinar Series. And today we're going to be covering the E980 hands-on session. Nigel Griffiths and Gareth Coates have been working with the early versions of these servers, and they're here to share their experience, or Nigel's going to be sharing his experience from this testing. Over to you, Nigel.
Okay, thanks, Jyoti. Gareth is in the background, probably answering a lot of your questions in the chat if you put them in. So we're looking at the POWER9 Enterprise machine, the big one, the E980. There will not be an E970, it's just the 2 nodes or the 4 node version of the machine. And this is the unofficial deep dive. This is my personal deck. I've been building this up over the past 3 months and opinions, so it's not an IBM announcement statement. You can't take us to court saying Nigel said that it works this way, because I may be wrong. Nice little get out clause there, I think. Okay, let's move on. Here's the little summary, and we're doing the presentation on the big one today. These are the dates, and we'll just go through those very quickly. We announced Tuesday, eConfig, it's an internal configuration program to design the machines, is now available with prices. And the small box, the mid-range enterprise, the E950 will be available later this month in August. And the E980, big machine, the 2-node version comes out in September, and then the full 4-node version will come out in November, including upgrading from the 2-node to the 4-node and migrating from POWER8 to POWER9 machines. IBM is very keen to get a quick start on getting a lot of these machines out. So before everybody asks, because this is the first thing that comes up in the chat box, where do I get the details? The PDFs will be there in the next hour or two in Jyoti's Power Virtual User Group. And if you want the PowerPoint, then you go to the AI Expert blog. You can see the URL below, a lot more information there, and other links to other places like the announcements and the performance data. Within a couple of hours, Jyoti will upload the recording, and that will be available. There'll be a link on the Power Virtual User Group. It's actually, I think, in YouTube. Probably lots of mistakes in here. Do let us know about those. We're doing our best we can to get the accuracy up. We've certainly had it cross-checked by a number of people. Now, the first thing I want to make sure is that we have these new POWER9 machines. They require that you have a HMC running the 920 software. For POWER8, it was 8-something. For POWER9, it's 9-something. And these will operate POWER7, POWER8, and POWER9 generation of computers. They've changed the numbering convention, so actually the 920 software is an update from the 910 software. So that's a quick update, not a big override install sort of thing. If you don't have the 900 software level running, you will never get your machine powered up. All of these machines require a HMC to control them. Now, we've had for a long time the Intel-based HMCs, CR7, 8s, and 9s are going to be supported with this software. But we have moved over really now to the POWER8-based HMC. And we've been using that for quite a long time in early testing and just use it for day-to-day operations now. This HMC comes with more CPU, RAM disks, and it's slightly lower cost. I mean, good move from marketing. Let's not make it £1 more, make it £5 less. And then there's no reason for not moving to them. And I think we'll find that the Intel-based HMCs will get into short supply, and you may not be able to actually buy them anymore. You should really move on. Now, the nice thing is that the Intel one and the POWER8-based one can cooperate. So you can have one of each, and they're very happy working together. You don't have a problem of moving up when the pace suits you. Of course, when you move from up to the 900 series HMC, it's all Enhanced Plus. There's no classical graphical user interface, so you must get the hang of that, preferably before your first POWER9 machine arrives. I have a series of 11, I think it is, small 5-minute videos on the Enhanced Plus showing you how to do all the basics to get you up to speed. So in 2 hours, watch a set of videos and you should be ready to give Enhanced Plus. But it's still worth they playing with it, actually giving it a real use. The 870 and 860 versions of the HMC software also have the Enhanced Plus as an option. Okay, oh, here's a note. If you've got still got Power 6 machines, they're going way back, aren't they, a bit? We've crushed all ours and sent them to the tip, or recycling. But the 9 series won't support to a Power 6 based machine. So if you still have some old Power 6 knocking around, maybe they're just used for general housekeeping or something, perhaps you'd want to keep one of the older HMCs to control that, and then you could buy some newer HMCs, or your latest HMCs could be upgraded to power the software required for Power 9. IVM support, a very nice way of operating. That's not supported any longer. We found not many people actually using that anymore. And as I said, the Intel machines are going to disappear rapidly. So let's talk about the processor. Now, we've been doing this for months, it seems. It seems like the last 2 years that in the technical universities we've been talking about the features of the marvelous processor after they announced it at the Hot Chips conference. So I've only got a couple of charts in here rather than the 20 or so we have, just to remind me some of the highlights in here. The Power 9 processor has 8 billion transistors, and that's almost double what we had in Power 8. So you have to ask, well, what are we doing with all those transistors? Well, part of it is building up the performance, but a lot of them are going into one specific area, and so we'll cover that now. This is the Power 9 chip. You can see there's some variations of that. The first to come out was this slim core version. This is used in the open power models, the AC922. That's the one with the graphics chips in there for doing lots of artificial intelligence sort of workloads and Hadoop and stuff. Or the LC922, which has come from Supermicro type machines. They're quite happily running the slim cores to boost the number of cores, but they're slightly weaker cores. The Scale-Out machines that we've had for a couple of months, 6 or 7 months now, they're using the fused cores. These are a bit like the Power 8 machines. They have up to 12 cores, and the full fat cores, all the strengthening the cores are there, and we can use SMT8. And these will be using Scale-Out machines. But now we're talking about these ones down in here. The key difference between this and the one above is that this has the Centaur chip in here. This is the level 4 memory cache controller. It increases the reliability of the memory, the RAS features, so that even more of the chips can fail and it will carry on running without interruption. But it also gives us a great big cache, which can boost our performance. So the E950, as we covered yesterday, is using this chip, and the E980 is using this chip. But this is the same chip as we had in the Power 8 machines. So if you're familiar with Centaur level 4 cache controllers, then you already know what I'm talking about. A little reminder in here, the slim cores have cut down parts of the processor attached to each thread. In the full fat that we're talking about in here, you can see these are the 8 SMT threads. This is the way to look at that inside a single core. And each thread now has a load store. This is the memory read and writing, integer mass and floating point amounts. They can have them if all the threads are actually busy. Then they can all have their own individual part of the processor doing the work for them. There's no competing for access to that part of the processor to do that operation. There's no queuing up behind the other 3 threads that want to read some memory, for example. So this really helps out the thread performance, and this is one of the key ways the Power 9 is a very fast machine. The threads are much stronger than they were in Power 8. And we can see in here, comparing Power 8 to Power 9, we've literally got 4 times the number of this part of the processor. We used to have 2. This is integer mass up in here. Now we have 8, so every thread has its own one. Same thing with the load store. We talked about those, and we got floating point and integer mass down here as well, times 4. And some of the ones that don't get used quite so often, we've actually just doubled them up in here, so that again we're twice as strong when we're accessing those particular parts of the processor in our threads. This is all good stuff, and this is how the Power 9, apart from the plumbing in the machine. All the buses and bandwidths are all jumped up. This is how we're getting the core performance up on our machines. Right. Now, there's a whole bunch of extra slides we could talk about the POWER9 processor, but let's move on to start looking at the actual machines in here. So the adapters in the POWER9 machines, they've all gone up to PCIe Gen 4. This is the same as the Scale-Out. There's a little note on the side there. Good for future-proofing, because this is where the industry's going. We're the first to do that, I think, across the complete product range. And this literally doubles the I/O rates that can come out the back of the PCI adapters. Really important when you're using 40 gigabytes or 100 gigabits per second type of adapters. So they're very fast adapters. Then they could really do with the Gen 4 technology. If you're running a 1 gigabit network, well, you could use Gen 3 or Gen 4 adapters. It doesn't make that difference because you're not going to hit the PCIe bandwidths. And I think there may be a couple of Gen 2 adapters will still go in there. They're all backward compatible, so if you've got a Gen 4 slot, then you can put a Generation 3 or 2 adapter in that slot, and it will scale down the performance to match the specification for those generations. Not all adapters are going to be supported at initial GA. Later in the deck, you'll actually find there's loads and loads of adapters. There's a couple that will be a little bit later, released a little bit later on. The other thing we have, again like the Scale-Out, is these NVMe adapters. That are disks. They're actually devices, but we're operating them as a disk. They have other features available that may be used later on. In the Scale-Out, they had a little thing. It's a little card about sort of 2 fingers wide and long, and it slips into a little socket on the motherboard. And a lot of your laptops and ThinkPads and things will have one of those rather than an SSD plugged into the underneath of your keyboard. So that's called an M2 device. Here we're using what's called a U2 device, and here's the picture of it. This part of it looks very much like a SSD, a solid-state drive, because it is a solid-state drive. But this is the front, and here around the back in here, this connector plugs straight into its own dedicated PCIe connection. So instead of it talking PCIe, talking to a SAS adapter, talking SAS protocol to a SSD that is actually talking SCSI commands, this plugs straight into the PCIe port, running at those very high speeds. That's how we get the performance up. So it's like an SSD, but with the brakes taken off, it can actually run quite a bit faster. The latency should be quite good as well. Now, in the E980, we can have 4 of these per drawer, or no drawer. And so we can have 16 in a 4-drawer machine. So there's plenty of these, and they're completely independently assignable. So each individual NVMe can go into a different logical partition or a different virtual I/O server. So you haven't got like the SAS drives where you get a bunch of drives with one controller, and the whole controller has to go into a virtual machine. In this case, because it's SSD technology, everybody says, yeah, this is going to wear out, it's terrible, it's fast but terrible. In here we have a write endurance of 2.4 drive writes per day. So we're actually talking about 800 gigabyte devices. So if you're writing 800 gigabytes into it every single day, it should last 5 years. And if it fails before the 5 years up, IBM will replace it. So it's pretty reliable. Difficult to know how much writing you do, but at the moment we're recommending that you use these for operating system loading, VIO servers, for example. They can fail, so we recommend that in a VIO server you'd have 2, and you do the regular VIO server mirroring between the 2 devices. Another thing people want to know is, well, if it is wearing out and we're hitting higher than the 2.4 a day, then it will be short-lived. Can I find out how it is? And down in the bottom corner in here, we have the NVMe Manager command. This is on AIX and Linux. It's on AIX. It's on the virtual I/O server too. and I'll actually show you a little report. You can see how worn out it is already, very simply with a little command. Okay, let's move on. DVDs. It's ancient technology. I hate DVDs. It takes an awful lot of time to burn them and then put them in the machine, and then quite a long time to install. I take, VIOS servers take like 20 minutes to install. It's old-fashioned tech. It's time to move on, and we have no DVD's internal support in any of the POWER9 machines. So what do you do? Well, you can use a USB memory key. All of the operating systems, AIX, VIOS server, Linux, and IBM I should put a note down in here. IBM I 2 can be installed from a USB memory key. A lot faster. We're now down to like 7 or 8 minutes to install a copy of AIX from a memory key. And we can reuse them, of course. We don't have to have a great big library of DVDs. We can just save the images on the server and burn them onto the memory key as and when we need them. Notice you should be using a DD in a Unix-like operating system to copy what would be on the DVD image onto the USB memory key. But we now actually IBM offers a USB-based DVD at a fairly stiff price, 122 euro dollar pounds. I bought my one from a certain world-known retail online company that's based after a big river in the Brazilian jungle for £20. But up to you what you want to do. The IBM one is a lovely sort of grey with a sort of etching effect on the top of it, and you can buy that if you want. If you're using a DVD drive, they take more electricity than a memory key, so you need to plug it into the front USB sockets. They provide more electrical power, so you won't get the DVD stalling if it overheats or takes too much electricity. Okay, but I strongly recommend we just stop DVDs. Some people seem absolutely wedded to having 24 cupboards full of 28 generations of IBM I DVDs, and I just don't understand why they don't move on. One little point, this is one down in here. This is the IBM one, plugged into the front of an E980. It's a nice little holster. This is actually plugged in, sitting on the door. There's a nice sort of flexibility of the cable being plugged in here, and you need a little paper clip to go over the top here so it doesn't fall out when you open the door suddenly. I tend to recommend now the USB 3.0 or 3.1 memory key. 16 gigabytes seems to be the sweet spot for the price at the moment. I use my favorite SanDisk. Also, it says narrow there. There are some of our computers that if the USB key is a little bit wide, like the size of your thumb rather than the size of the USB connector, you can't actually get them to fit in. There's things around the slots, you can't get it in. It's a nice narrow SanDisk ones which I use, but this is my personal opinion here. Okay, let's look at the server range. This slot was filled with the POWER8 machines with the E980 and the E980. They were always technically the same machine, two marketing slightly differences, and it's going to fit in exactly the same place in the range. We talked about the 950 yesterday. You'll notice, whoa, listen up now, that the system control unit is at the bottom now. With the POWER8, it was in the middle, and I've seen a lot of early POWER9 PowerPoint decks with the system control unit in the middle, and it's absolutely obvious that's a POWER8 box, not a POWER9 box. So look for those. It's good trying to find these old ones. Here's the open power boxes down in here as well. But I think we should know that if we've been around any length of time. Let's look at some of the model details in here. This chart is a summary of everything you need to know. It actually looks like one of the data sheets you can download as well. So we have the 4 sockets, POWER9 sockets, and each each node can have 32 to 48 CPU cores. Every E980 node or drawer, some people call them CEC, Central Electronic Complexes. Each of them has 4 sockets, and they have to have all 4 chips, POWER9 chips installed every single time. You can't have a 2 socket filled 2 empty sockets in any of the E980s. Oh, this is the machine type model in here, 8080 M9S. Okay, we'll have to get used to that. The 4 sockets per node, okay, for nodes if you want. Here's the memory details. We'll look at that in great detail. Cover the DVD. I probably won't say anything more than that. Oh, there's a flash socket in the system control unit. We'll cover that. I've had some questions about that. I didn't understand what was going on. Yeah, lots of Gen 4 adapter slots in each of the nodes, 8 in each node. So it's 16, 32 in the whole machine. We have remote I/O drawers, and we have remote storage as before. Given the fact we have NVMe disks inside, perhaps a lot of people will say, let's get rid of these external drawers. It saves us quite a lot of money and quite a lot of complexity. Don't forget, every time you add more components to your computer, you're actually reducing its reliability. There's more things to go wrong. So if 4 little NVMe devices will run your VIOS servers, that's a whole lot better than a couple of adapters running out to remote storage drawers that could go wrong, and then having brown spinning disks or SSDs out there that, again, could go wrong. Okay, we'll look at the operating systems in detail as well later on. IBM I, these are the latest versions. I'll get JT to say a few words when we get to that page. Right, so moving on, this is the system control unit. It's quite a bit simpler than the POWER8 machine because it no longer is supplying the clock signals to each of the E980 drawers, or the nodes we'll call them. That makes things a lot easier down in here. We can see we have 2 FSPs, the flexible service processor in here. There's the connections here, 2 power cords. This comes, if you only got 1 node, then they both come from the same node. If you've got 2 nodes, they'll come from different nodes, so that the power supplies are actually in the nodes. They're perfectly good, powerful power supplies, rather than having the system control unit have yet another power supply. And these are the connectors here and here that we connect to each of the nodes. There's 4 nodes, so there's 4 cables coming from these connectors, 1 for each service processor, so they're completely independent of each other. Classic sort of buttons and LED panel. This is the system USB. So this is the one you should plug your DVD in if you really insist on you being old school. These USBs are not for public use. These are for initial installing of the machine at the factory and maybe doing some diagnostics and dumps and that sort of thing. So they're not common use. Don't try plugging those in and seeing what happens. Moving on then, this is the node, the front of the node. Interesting design. Just like the POWER8, the power comes down a tunnel from the back to the front. And then actually plugs into the power supply at the front, so you can see 4 power supplies in here, and we have 5 reasonable sized fans that's keeping the whole machine cool. The power supplies have got fans as well, I think, and they're pumping air through the machine as well. This is round the back in the the last third of this presentation. We'll actually see some pictures of that can be more helpful. We have pretty similar to POWER8. We have the 4 PCIe blind swap cassettes in here, all Gen 4. Here is where the NVMe slots go in. They look like the credit card size SSDs, and you press the button and pull the handle out, and then they'll pop out at you. Down in here, we have the service processor ports in here. This is 3 USB sockets on each KEC, so you've got plenty of USB if you want, and each KEC USB can be assigned to a different LBAR if you just want to read some data in, for example, or I suppose you could do some sort of backup or save data to a USB memory key if you wanted. These are the sockets to put the power in that goes down the front. And the big piece across the middle here, these are all the sockets in here that go from each of the processors to the other nodes. And we've got big diagrams that will go through that, so I'll skip on forward. Okay, so do it right now. How do we turn via cables the 4 nodes and system control unit into one computer? Right, so looking at the service processor bit part at the start, at the bottom, system control unit, we've seen those 4 ports in here, one for each node, and one for the left-hand service processor, and one for the set for the right-hand service processor. And you can see that each of these little connectors in here go to the 4 ports up the machine, and it's all pretty simple and straightforward. We can all, I think, handle that, and in the documentation is clear instructions on which port goes to which machine. Okay, not rocket science in that case, very simple cables. Now, a little reminder in here, sorry, there shouldn't be a 5 in here, that's a typo. So if you look at the processor over in here, it has 4 sets of buses. All right, so there's the lanes of the PCIe that go out to the adapters. It has all the connections for memory. We'll talk about that later. It has this X bus for SMP communication inside a node, and then it has these A buses for communication outside the node going to the other nodes. So inside a particular node, you have 4 POWER9 processor chips, and they're all directly connected to its friends, straight, one hop to the other chip. Makes this nice and fast, nice high bandwidth, and so a node very quickly becomes a whole computer. But when we actually start joining nodes together, we start using these A buses up here. Right, so we've covered that diagram in here. Now, if you look at this portion here, we have 4 double sockets, if you like. So ignore the doubling in here. These 4 are directly connected on those channels that we saw coming out of the POWER9 chip, the A buses. They come straight out. So this 4 is connected to CPU 0, CPU 1, 2, and 3. Typical techie starting from 0. So that's the ports that literally directly coming out of the chip straight out of this port, and then we're going to connect these ports together to join the CECs together. So we're running an SMP type machine. Now this picture actually covers the 2-drawer, 3-drawer, and 4-drawer case all in one go. There's a picture up in here. You can see if you look at the first node down in here, there's a bunch of cables coming out in here, comes around here, and goes to, this is the chip, CPU processor 0, and there'll be 3 cables. Each of the cables is paired, and the pairs go to this CEC, and this CEC. And then the next 4 in here, there's 3 cables coming out for chip 1, going to this CEC, and this CEC. And then there's another set here for CPU processor 2 and processor 3. So there's 3 cables going, which are doubled for 4 CPUs, so that's 24 cables. 3, 4, 12, and the doubles, so there's 24. There's 24 cables coming up from this CEC to all the others, and the same for each of the other nodes. So this does actually build up to quite a lot of cabling coming in here. And we'll talk about racks later. This is why you need plenty of space at the back of your rack. And I certainly wouldn't have a PDU tucked into the side of the rack in this case, because that's going to be a real mess trying to get power cables to PDUs down the side, and why we recommend PDUs being at the top or bottom of the machine. Right, so in the 2-node machine, this is processor 0 in CEC 1, directly connected to the processor in CEC or draw node 2. This is a double cable in here, so if one arm of those cables are duplicated, they're both operating. If one of them fails or gets unplugged for some strange reason, it will carry on running at reduced speed, of course, on the other cable going between the 2. And in this particular case, it actually has another set of cables over here. So this is like a particularly sweet spot where we double up the double up, talking between the drawers. If we go to the slightly more complicated functions, if we add in the 3-drawer case, you can see it's not quite as simple. If you look at one particular CPU in drawer 3, then you'll see it has the yellow going to the drawer below and the blue going to the one even further away. The colors are how long the cables are in here. It's just how many, make sure you get the right cables in each. And you can see there's a sort of symmetry down the middle in here, the left and right, so they're sort of mirrored each other. Okay, if we carry on to the 4-drawer case, it's getting a little bit more complicated in here, but again, every drawer now has, we've got 4 drawers, so every drawer has 3 connections to all the other drawers. I can't quite see the pattern they're following in here, but it's much the same as before. Okay, and I think the idea is, yes, if you've got a 3-drawer 3-node machine, if you add the 4th drawer, you're just adding to what the cabling you've already got. You don't have to change anything to add the drawer. Okay, right. So that's covered that off. Lots of cables. This becomes one computer. We don't have any clock cables like we did on Power 8. In Power 8, the system control unit had the master clocks in, duplicated, although we haven't had a clock failure for 40 years. But everybody says, single point of failure. So, well, it hasn't failed in our lifetime. But, we put in 2 because that gets the tick in the box. Now we don't have any. Well, we do, in fact. We have a clock controller, a pair of them in each separate keg. And the only time that this is important is when the 2 kegs are talking to each other, because they're effectively running, passing pieces of memory between the 2 nodes. And we want to do that as fast as possible. And if both nodes are running at the same clock frequency, then that's easier to do. Now, it turns out the cables we're using have great big connectors at the end of them and CPUs in their own right. And so that the clocks, the cable is quite expensive, but the processor managing the cable is quite intelligent, and it will, if they're off by a few clock cycles on the gigahertz that they're actually running, they don't actually mind. They're just interested in getting the data from one end of the cable to the other end of the cable and writing it into the memory, and they don't have to be absolutely in sync anymore. So from going from 2 clocks, now if you have the 4 nodes in here, you have 8 clocks in the machine. So that's very redundant, and we're not sensitive now to a drift of gigahertz between the different nodes. That's all handled by the super intelligent cabling. Okay, we've already mentioned these. Each node has 4 processors or Power9 chips, and these are the dates for the 2 versions coming out. So let's have a little look at a top view. We've got a lot more pictures coming up later after the top of the hour. But here's looking down the top. Out the front in here we have the fans and the power supplies. Everything in blue in here is a VRM, a voltage regulator module. This is smoothing out the 1 volt, and some components need 3 volts. Power supplies into all the expensive equipment in here. These VRMs are meant to commit suicide rather than let a voltage spike go through to something that costs a lot more. And it means because it's super smooth, we can actually go faster in the components. All these black things in here are the memory slots. We're using the CDIM type memory in here. We can clearly see the 4 heat sinks on top of the processors, and we can see a couple more of the voltage regulator modules spread out here for the processors themselves. Out the back, of course, we have the PCIe hot swap cassettes. We've got lots of pictures of this coming up, so let's move on. Okay, the chips come in the individual processors. The Power9 processor chip comes in 12 CPU cores, 11, 10, or 8. And then in a node, you have 4 of those, so just times by 4, we get these numbers in here. These are the frequencies that we expect these to be running at just about all the time. It's called the max gigahertz. This is the default gigahertz rating you should be running at. We'll talk later about if the machine gets very warm, so if you have a very high config, all the maximum CPUs, the maximum memory, the maximum number of very high performance adapters, they can get hot. You can see the heat sinks on them when you put them in. and you're running absolutely every thread in the whole node or the whole computer, then the temperature can rise. If your computer room is fairly warm, then the box will start getting warm, and it will actually slow down the gigahertz to these numbers. Unfortunately, we don't have a special name for them, so I've been forced to call them the gigahertz with no name. It can slide down in the gigahertz rating down to these numbers. If you switch off the variable frequency handling of the processor, you get to what's called the nominal gigahertz number. So we can run within the supported environmental environment, the temperature in the computer room, the humidity in the computer room, and the height above sea level. If it's in what IBM agrees to, and that's very clearly documented, then you can run any computer at this gigahertz all day long. Of course, you're missing out on quite a big performance jump by not running at the maximum. But that does give you a fixed frequency. Can't see why you want to do that. Everybody wants to go as fast as possible. An example maybe your air conditioning units fail in half of the computer room, so it goes up to 32 degrees Celsius in the computer room, and that is too hot really, so we may be sliding down. And some people really can't sustain the fact that yesterday we were doing 20 billion transactions an hour, and now it's gone down to 18. Why is that? And it may be something going on in the computer room outside your control. You should be aware of it, of course. But there we are. That's what's going on there. Then we looked at the performance. Similar number of diagram in here, nodes per core, nodes per system for the 2-node and the 4-node system. And here's the RPERS and CPWs. Now, in the performance report, it's got a link down in here, or it's in the AirExpert blog, you've got a link. There's lots more RPERS numbers. These are the top numbers. There's RPERS for SMT4 and SMT2 and SMT1. I don't know why you'd be doing that. And the same for the CPW numbers. And you can see as the number of cores goes down, the RPERS or CPWs go down a bit. Not terribly. It is between 11 and 12. It's not that much, actually, is it? We don't know what the price difference is yet, as the prices have only just been released this morning. So that'll be interesting to see what sort of cost effective. A lot of people might go for these 11 core chips. I've no idea. We'll have to see how that turns out. Okay. And so my quick look, just to give you a feel for what's going on, I looked at various machines down through history, which sorry, I clicked the wrong button, which could support 192 CPUs. And compared to the Power8, you can see we've got a 30% performance jump. Faster CPUs, higher bandwidths for adapters and memory and those sorts of things. This is cheating a little bit. This machine had 256 CPUs, but even then, if you have a 795, you can see 71% performance boost if you go up to Power9, or maybe you'd buy half a E980 to do the same sort of workload. But it's good to see these big numbers. I always see certain competitors introducing new chips, and it says, and it's 3% faster, and we sort of say, what? Why would you bother? Okay, moving on. Memory. Okay, now, it turns out in the Power9 processor family, there's three sorts of memory, but we've got the top dog here in the E980, much like we have with the Power8, as it turns out. So we have lots of buffered channels coming out of a processor chip in here, and these go into these special CDIMM cards via the Centaur level 4 memory cache controller that provides extra RAS as well as caching. Okay, and we expect all the current CDIMM memory modules in the Power8 machines will be able to be migrated to the Power9. Nice to know that investment in Power8 can be brought forward into the faster Power9 CPU-based machines. Okay. Oh, and here's some details per nodes, the bandwidth, per machine, the bandwidth. 32 of these, well, there should be a CDIMM there, not on a DIMM. They're custom designed IBM only pieces of memory with a Centaur on it. Various sizes in here, starting fairly large, because we've got plenty of chips to put on the actual chip itself, and we can handle DDR3 and DDR4. Only a particular node or drawer must be of the same type. So we can have a drawer of DDR3, perhaps we bought over from an older Power 8 machine, and then we're going to add to it some DDR4 memory in a different drawer. We can do that, okay. All right, and we can do capacity upgrades, stuff like we could with the Power 8. So these are the actual ones in here. Some of these are blanking plates. You can see the darker ones in here. This hasn't got a full complement of memory DIMMs, and this is what they actually look like. A little filler up the top in here, which allows for airflow. The silvery thing underneath here is the Centaur chip, and we can see the actual chips in here for memory. Loads of them. This is similar technology that you get in a DDR4 industry standard DIMM, of course. They're actually low level, so this is a nice thin card rather than sticking out quite a lot. But if you count up in here, there's 10 of them in here. So this is the extra chip kill features in here, and lane failure protection built into these special memory units. Okay, let's look at some infrastructure things. How does it all plug together? Well, this is our one node again. We can see down below every Power9 processor is running a couple of the Gen 4 adapters in here, and they're all in the Power E980. They're all Gen 4, so we've got 8 Gen 4 slots at the back of the machine. We can see they're all CAPI enabled. It's in the machine now, but we're not actually making that available at this release. That'll be later in the year, or perhaps next year. USB, well, you've got to have one apparently. Everybody wanted that. These two processors in here are providing the PCIe connection to the NVMe's, two different chips. I mean, I don't think you need to worry about that if you have a whole Power9 chip failure. I think the flash disks are not that important. We can see in here with ×2 performance jump in the connecting across the motherboard inside the machine, and ×4 increase in the SMP between the actual nodes coming out the top. Remember, each one of these goes out to 3 other nodes. That actually leaves one, and we've got a different color on there, and that's where the GPUs or a high-speed remote drawer may be going for I/O adapter slots, or CAPI adapters and things like that, maybe using that extra 25 gigabyte channel that we're not using at this release. Oops, wrong button. Try that one. Okay, let's look at some sort of infrastructure things in here, or differences, or Power9 chip. Okay, double the amount of memory going in here. That's because the individual chips have doubled in the past 2 years. We can upgrade. We can take the memory from the Power 8 machines and put them in here. We can. Somebody's asking about blind spot cassettes. There's loads of pictures coming up. Don't worry. Okay, adapt slots. Yep, Gen 4 in here. Future CAPI and Open CAPI. This is really CAPI 3. I/O bandwidth doubling up. That's the Gen 4 effect. We got USB. Everybody complained about us having to put a $5 USB technology into an fairly expensive, exotic, very fast PCIe slots, so they're built into the machine. We now have the 4 disks in every drawer, which is really nice, enough to run your VIOS servers, and the drawer fabric's running faster as well. Okay, let's carry on. I keep missing my page down button. Okay, carry on, and I'm hitting page up, so let's carry on. Okay, now some of the other enterprise features that you expect with our top machines. We have, well, the marketing people call it built-in PowerVM. Well, it's always built in, but it's switched on, and you don't pay for it. It says at no cost in here. Careful wording. You still have to pay the SWARM, the software maintenance for PowerVM, but the bulk of the price is already included in the price of the hardware. PowerVC is in there at no cost, again as a swarmer. You get the Power Cloud Rewards, which is for skills transfer type education or lab services days, doing things with you. The Cloud Management Console, this is getting some of the information from the HMC shipped out so you can connect to your mobile cell or your mobile phone or a tablet and get updates about what's going on in your computer, how busy is it, and if there's anything wrong, you want to manage it like that. You can't proactively manage it, you still have to go to your HMC to actually go and fix any problems. Warranty, 3 years included, 24/7. Some regular things that people actually like, but these are at cost. They're just the same as in Power 8. Elastic capacity on demand for processor and memory, so you have more in the machine you need, and you pay to switch on the extra bits when you want it. We have the enterprise pool, so you can have the licenses for CPUs and move them around a pool. There's a note in here, N+1. You may have a Power 7 and Power 8 pool at the moment, but the Power 9 can't go into a pool that has Power 7 machines in it. So the idea is you should migrate permanently your Power 7 licenses into Power 8 licenses, but then you can share them between the Power 8 and Power 9 machines as you will. There's also the active memory expansion for AIX as a feature. The active memory mirroring is included in the E980, let's say at price feature for the E950. Okay, let's have a little bit more of the sort of details of the actual bits and parts that you're going to have to configure when you're buying a machine. So we've seen this already in here. We have the feature codes, so you can make sure you get those right, and we've seen these numbers before. Up in here, this bottom number is the frequency with no name, and we tend to tell you these a range of frequencies now. Most of the times you'll see probably on the next chart is the time it will be running at the top frequency, and the biggest box runs at the highest frequencies. You somewhat expect that. Okay, so let's carry on. Yeah, this is a chart I could do an hour's worth on it, and from discussion yesterday, Jyoti will schedule a session on the virtual user group for let me to go to full gory details. I've already mentioned some of this. The default for the E980 is you'll be running at what's called max performance mode, and getting the max gigahertz, those numbers at the top, or at the right of the previous chart, the higher gigahertz numbers. If there's we'll carry it in a minute, but it will, if necessary, because things are getting hot, it will go down to the no-name gigahertz rating. So most of the time it'll be up in here. In desperate situations, it will go down to this value. If your computer room goes above 27C, which is pretty hot, I mean it's 80-something degrees Fahrenheit, then it reserves the right to actually clock down to the nominal. If that means we keep on running rather than have to power the machine off. If you genuinely get the machine really hot, it will actually power itself off rather than allowing itself to be damaged. At least you can then power it on to recover once you fix your heating problem in the computer room, rather than asking IBM to supply parts to your machine. So this is what this is all about in here, and we're going to cover that in another session. That's hopefully explaining some of those mysterious gigahertz ratings. If you're on Twitter, and you all should be, shouldn't you? I put out a little tweet a week ago. In practice, the Power 9 machines are running between these two. Other server chips, I'm amazed when you see the Intel charts that say, our new chips run at 2.5 or 2.6 gigahertz. You think, good grief, it's really slow. But there we are. They seem to be going down over their generations these days. So I look at these high gigahertz ratings as sort of normal, the nominal values, plus the amount of overclocking we got in here. But I'm told I shouldn't be using this overclocking word. It sort of makes it sound like some teenager in their bedroom overclocking a gaming computer. But anyway, the energy scale guys that are doing the controlling of the gigahertz rating based on the energy numbers that they're getting reported every couple of microseconds. They say we run at full speed, but we reserve the right to lower the gigahertz if it protects the machine, or things like your air conditioning fails. Try and keep the machine running a bit longer before we have to power it off if you're slowly getting hotter. Now, I've actually tried to get my machines hot, and I couldn't do it. I tried, couldn't get it to do it. And then the developers are explaining, well, Nigel, you haven't got the maximum CPU count in here. You've got the early machines that don't have the 12 cores, so okay, can't do anything about that. I don't have the maximum memory. I don't have the 16 terabytes per node, and memory at that scale does get hot. The disks are ridiculously hot, but we don't have disks. We only have the NVMe's in this machine. I don't expect them to get hot at all. High-speed adapters can get hot, and of course you have to be really logging the machine, every CPU core and every thread, and then that's when it's going to get the maximum temperature. And maybe the computer room is getting a bit on the warm side, and then it will kick in and come off the maximum gigahertz. So you may spend your entire life in a nice cool computer room with not maxed out config and never come off the maximum gigahertz rating. I'm noting down in here, this is a bit depressing for me, commands like lparstat -E will tell you, as you can see up in here, this is an early machine, so it's not a regular one, but it's running at 3.7 gigahertz and it's 13% overclocked. Oops, I'm not allowed to say overclocked, but that's what the 13 is telling you. That's fine, but if you go to other commands, and nmon in particular, it will give you the nominal rating, so it may be reporting this machine is 3.3 gigahertz. And I'm worried about people saying, hey, I bought the 3.9s and nmon says it's running at 3.3, but that's because it's showing you the nominal gigahertz. I've got PMRs registered to try and get them to fix that. If you don't like it, feel free to raise a PMR, because there's nothing like a customer-based PMR to get the focus of the developers. And it's not like rocket science to fix that one. Okay, looking at the memory, here's the different sizes of memory. They're actually banks of 4 that they go in as. We covered these sort of CDIM sort of things before. 128 of them can go into one drawer. It's very dense because those cards are very thin, and you can put a lot of them across the machine. You saw where the slots are. And I said it before, we can even use the older DDR3s in individual cakes. So if you're using your VIO servers, well, of course you should have 2 VIO servers, dual, maybe quad even, if you're thinking of production and everything else. But your networks, for every VIO server, you'll need 2 or 4 for a bit of redundancy if you're Ethernet. On the storage side, you've got up to 16 NVMe's. That will give you, with mirroring in there, 8 VIO servers. That's probably enough for most, running off a deliciously fast NVMe drive. And we can replace those live, like you can replace a disk live if you actually have a failure in those. We have no internal disks or SSDs, so we can't do that. We could use fiber channel for booting our VIO servers. That's pretty normal if your computer room is running a nice big SAN. And that's business as usual, so I would say it's a toss-up between the fiber channel and the new NVMe's. The nice thing is that if you boot off the NVMe's, you get your VIO servers up, and then you can experiment what went wrong with the fiber channel. If you're on the fiber channel, you can't actually get anything running to investigate the fiber channel problems if you're into serious problems in that direction. Or you can go adding remote disk drawers, and the general trend in the computer industry is lower numbers of very high-speed adapters. 1, that keeps the price down, 2, that keeps the complexity down, and 3, that increases the reliability of your computer. But we still get some customers that insist on, 100 adapters in the back of the machine. Well, that's okay. The customer's always right. If they want to make their computers very expensive, they have that right. If they want to have 5 spare tires in the back of their car, clogging up the place, they're entitled to. But I wouldn't recommend that. Okay. In the NVMe area, we have just the 800 gigabytes. That's plenty enough for a VIO server. We may be able to do some experiments with the flash cache features of AIX and VIO servers in there as well. On the E980, the smaller machine, there's actually 2 double and quadruple size NVMe. This has the same part number as the NVMe in the E950. So we actually moved some from the E950 into the E980, and this was fine. Same part number, the same feature code. That's going to work okay. Right, moving on operating systems. Alright, going to do these fairly quickly. AIX, nice little chart in here. We're down in this red box in here for the E980. Yeah, I should have removed the H's. This is the HANA version of the machine. It'll be exactly the same config-wise. Of course, SAP HANA are fairly prescriptive in what combinations of CPUs and memories that you can have in your machines. That will be announced as soon as we have the SAP HANA certification, which we're expecting fairly soon. But so ignoring that, you'll see that these are the versions of the operating system in here. Well, you can look at the key code in here and work out what they are. In text, we got the details in here. This is the latest things in the new versions of the AIX. There's a TL3 coming out later in the year with some nice features in here. So ignoring those, day one for the GA date for the E980. These are the virtualized AIX, so they're running virtual networks and virtual storage. This is the AIX 7.2, TL2, Service Pack 1. This is the year and the month, the week in the year. So these all came out, over a year ago. So you should already be running these versions. And if you are on your Power 7 or Power 8 machines, then you can immediately do live partition mobility straight into your Power 9. Now you'll still be running in your Power 7 or Power 8 mode, but you will get the vast bulk of the performance boost that you'll get with Power 9. That's not dependent on adapters and things. If you have AIX with adapters in it, then it's quite reduced in what versions of AIX you can run. Here they are, these two, and there's the new one, the TL version will come out later in the year. Okay, so it's compared to the 950, it's the same, but this will actually be available by the time the 980 comes out. Later on, we'll also get testing some of the older releases of AIX, and they'll be fully supported with adapters. Of course, you've got NVMe, for example, as an adapter. If you're running an old copy of AIX, that's not going to have the device drivers to run things like NVMe. Linux, very quickly, SUSE and Red Hat. The E980 only runs with a hypervisor for PowerVM in it. We don't have like an Opal direct native mode, so don't worry about that. Older versions of Linux have been out for a little while, are fine running on the E980 in Power 8 mode. That's sort of business as usual. If you're looking for some of the Power 9 benefits other than the vast bulk of the performance, particular features, then the vendors of SUSE and Red Hat are putting some of those features in their recent releases this year. So go and ask them about how much extra support or performance you'd like to get running in Power 9 mode. The best chances are running SLIS 15 that's now available and Red Hat 7.5. Now I had somebody trying to get the Red Hat to run on the E950 and the E980, and they can't find it. They can find Red Hat, but we told them to look for Red Hat 7.5 for Power 9, and it's not on the Red Hat website as far as we can find. They've now called it the alt version, alternative. So you're looking for a download file that looks like that at the moment. Some of the numbers will change as they do updates. So it's getting hard to actually find that. So IBM is also known as It's Been Moved, but Red Hat has been moving stuff around their website, making it hard for people to actually find the right version to support Power 9. Now, canonical unit, Ubuntu. Odd story in here. This has not been well publicized, so I decided to bite the bullet, and I've had permission to do this. Ubuntu on PowerVM is no longer being supported by IBM. That's a bold statement, isn't it? It includes 16.4 and 18.4 that's now out on Power 8 and Power 9. Now, just because we don't support it doesn't mean it doesn't actually work. And I've run it a bit of Ubuntu on these machines, works just fine. There is no support. In the past, if you bought support like from Canonical, level 1 and 2 would be done by Canonical themselves. If they think it's really a hardware issue, they could pass it over to level 3 support in the IBM Power support group. But that's the bit that isn't there anymore. They were a bit worried about the order of which they did things, because this is a bold statement, it's very bad news, but hang on, it's not as bad as you think. If you previously purchased support for Ubuntu 16 running in Power 8 mode, that is still supported. If you pay for support, we support you, and it will carry on for 2 more years, and that's the lifetime of 1604 as a long-term release, I believe. Maybe I've got that wrong, actually. But anyway, we'll support you for 2 more years, so don't panic. You don't have to get off it. It will still be supported as we promised. Now, on running Ubuntu native, by which I mean not PowerVM, or sometimes called base metal or native, so we might be running it like that for running it on the AC922 to get access to the GPUs, for example, on the AC922, or you may be using it on the LC92 921 for hosting lots of cloud-based KVM type operation. The mode is actually also known as Opal mode, but you may or may not come across that. That is still fully supported by IBM, and that's critical for these 3 IBM machines. So that's, as far as I know, it's not going to go away. So I hope I haven't scared you all there. Yeah, I'm a little bit disappointed, but there we go, that's life. Okay, IBM I. These 2 releases are supported. There's some big announcements going on. I'm going to pass back to Jyoti, if you're still there. Got any comments on these 2 releases? Go for it.
Yes, so just one highlight in terms of new technology releases for IBM I 7.3 and 7.2. As it's past TR levels, there is a lot of function enhancement in these. So along with support for the E980 hardware support, there is a lot of improvements and enhancements to the DB2, as has been the case with previous TRs, in terms of the database performance, services, DB2 web query. The easy install has been enhanced even more. RDI, so Rational Developer for I. We've got PDM coming to RDI. So if you really use your SU and PDM interfaces and hook to those from past, then it is now part of RDI. Access Client Solutions, a lot of new stuff in there as well. So and some open source additions. So rather than me rattle on through each item, the best write-up, apart from the announcement letter, the links that are at the top of each of the TRs in this slide, the Developer Works technical info, the technology update pages are actually better in terms of readability and the information that's out there. And I believe Steve Will has also done a blog about these TR levels. So look at those for more information. I'll post these links along with the replay later today.
Okay, thanks, Jodie. I've got to get motoring now. VIOS server 22630. Don't try anything before that on this machine. You might as well start with brand new latest release of VIOS servers as it comes along. VIOS server 3.1 is still coming this year based on AX7.2, but we're not forcing everybody to do that when they take these enterprise machines. Okay, storage adapters and in remote drawers and that sort of thing. Just like Power 8, we're supporting the same drawers. For I/O, again, we've got the same drawers. Always confuses people a little bit because the drawer has 2 fan-out units with 6 more PCI adapter slots in here. Reminder in here, these are the sort of fan-out units with 6 slots. This connector goes back to the server and will take up a slot in the server. So you're 1 down because of this, but you get 6 back. So each fan-out unit gives you 5 more adapter slots. You can have loads and loads of them in here. Here's the this is the adapter list and the disk list. We put in here the feature code and the CCIN numbers. That can be useful for what's actually written on the back of the card. And I'm going to whiz through these. Oh, there's one little thing in here. You see it says 32 for this. This is because this is a low profile card. The servers take low profile cards, but the remote I/O drawers have full height cards. So if it says 32 in here, these are the ones that are going to actually inside the server itself. But let's flip through these. You can go back and do it. Let's look at some of the physicals in here. Same as the E980 as far as I can see. T42 rack is a very tight with all those cables at the back joining up the machines, just like the Power 8 machine. So there's an 8-inch extension for the highly recommended. Don't put your PDUs down the side. I think the other facts are much the same as the Power 8, so I'll whiz through those, but I thought I'd collect them all together in here. So here's an easy to remember fact sheet about the machines, and if the technology is winning, I'll quickly flip over to my first look, and we're going to whiz through these as well in the last 20 minutes. Only 80 slides. Okay, 75 slides I've got here. Okay, so these are the guys that put this machine in. This is well, it's called SSR. I don't even know what it stands for. You know, CEs will put the machine in, but maybe business partners are allowed to do that as well as IBM CEs. Here are the guys who did it. This is our local CE for our computer room, and these are two PEs, principal engineers from Human, that flew in to watch the machine be built. They're actually watching the CE do it and making notes of any problems he has. So he's a bit of like a master class for poor old Mike. Here's a different mic. This is Mike Pearson. It arrives in June like this. Remember, this is supplied by the developers. This machine actually has been switched on in the development lab. They packed it back up into the crating, and we're well advanced in that. Sometimes they come in all sorts of boxes. These are made-to-measure boxes. So this is the system control unit as it arrives. Here it is on the deck. Here's the front and back pictures. Remember, you can get these in PDF or the actual PowerPoints if you want to have a look at them in detail. These are the USB you don't use. This is the USB you can use. It has extra electrical power to run your DVD if you really insist. Okay, here's a little step in to have a look at them. 3 fans across the front. No power supplies in here because they connected in here to the first 2 kicks normally. And these are the 2 service processors. Behind the blue covers is the time of day battery, so we can just pull the little cover off and replace that without fiddling about inside. Okay, I just pulled out the fan because it's the sort of thing we do, and this is a development style box of bits of all the cables. It'll be more organized when it's shipped from the factory in Mexico. Here's the actual node itself. We only have a 1 node configuration in here, and oops, this is back to the system control unit. There's actually a warning in here. This is our engineering prototype, and warnings about the lifting this. Highly recommend using the proper lifting tool to lift these things in. They are worth an absolute fortune, and we don't want you damaging our beautiful computers by dropping them on the floor, yet alone the physical damage you can do to yourself. They are heavy. Now the system control unit, it goes into what we call a shelf. It just plugs in. There's no rails to pull it in and out. Steady light. I think 1 person could actually lift it, but we're putting in 2 to make sure we don't drop it. Here it is going into the rail. No rocket science in here. Apart from there's no clock cables. It's much the same as the Power 8 guys. So there it is, plugged in, screwed in, and it's looking good so far. Then they prepare reading the manuals in here. Again, it's an expensive computer. Read the manual and follow all the details bit by bit. I'd actually put a great big tick about each section as you do it, so you can make sure you don't miss something out. We're actually using the Power 8 manuals because the Power 9 ones are not available. The documenters don't like starting early on the documentation because there can be all sorts of subtle changes in the development process, and they don't want to rewrite the document again just at the last minute. But the bulk of the Power 8 manual will actually work fine. So here is our node. You'll see these has great big hard metal transfer covers on, so covering the sensitive bits front and back. Obviously, it's a bit of a shame. You're going to put these in a cupboard or throw them away once they've actually arrived. It's no use of them later on. I guess you want to keep it in case you want to sell it second hand in 5 years' time. We also noted that they have thin little handles in here. Well, it's the CEs are going to lift this. It's not customers, so we don't care if it hurts their hands. The E950 had lovely round customer handles because customers were going to install the smaller box. So we've sorted out the rails. These are the power connectors up in here to connect to the system unit to power it up. of bits and pieces. Oh, here's the USB connector, the cable. This is just like a pass-through. It passes from the KEC, the node, into the back of the system control unit, and then there's just, again, another straight pass-through, like a cable extension, to the slot at the front of the machine. You can't plug in and use with a DVD or a memory key. The one at the back of the control unit has confused some people. That's the in socket. It's a USB ingoing socket, the one at the back of the control unit. I had a lot of questions that last time. This is the sort of cable we use for between the node and the service processor. Covered that. Why we'd have some of those later on. We were sorting out all the bits and pieces. You'll see where all these come into play as we build up the machine. They sorted out the rails. Here's the rail. I think they're exactly the same as the POWER8 rails. I don't know if they've made subtle changes to improve it at all. There's a R, I'm not sure if you can quite see it there, telling you this is the right rail, which is a nice thing to see. And the CE has told me, he said, yeah, we've seen these before, much like the POWER8 rails, so they're screwing those into the rail here. This is the left one about to go in. Here's the node. We've lifted it with 4 people onto a table, most because we want to take a load of pictures, but with 4 big screws you take out and take the covers off. So here's the back of the machine. These 2 areas in here are the. In fact, I've really got the next slide. Oh, no, okay. These are the where the clocks are. Go in these little covers at the back in here. A pair of those. Power goes in here. These are all the adapter slots, the blind swap cassettes, and these are the NVMe. Press a little button, arm pops out, lower the arm, and out it comes, just like you would a disk actually. Okay, USB's down in here, and these are the connections between the machine. You can't quite see here, just the bottoms of the connections that would connect the other nodes if we had them. Blind swap cassettes, there's some questions on this. This is what it looks like. Press the blue button, push the cover back, and it just comes off. Very, very simple, 2-second job. If we carry on, if you look at the top, another blue button, bit of a clue. Press the button, push it back, and that comes off. Okay, so now we got the adapter and the covers off in here. We pull these are the stabilizers that go onto the outside of the adapter. Push those down, and they'll slide off out of the way. And then you'll find that because you've taken the front top cover off, the tailstock is free, and we can just pull out pull it up and lift it out the adapter. Now we were going to play some games on how fast we could do this. I got it down to about 17 seconds. It takes slightly longer putting it together because you've got to get the slot lined up and the covers put back in the right place. But a very, very quick 1-minute operation to change the adapter. Don't let anybody else tell you differently. So here's all the various bits, and look, it even tells you what to do. Really nice bit of tech. Okay. And we thought, well, these look very, very similar to the POWER8 ones. We didn't actually try swapping them between the machines. We talked to the developers, and they said, nope, they're slightly mechanically different. They're a little bit slimmer because they had to give some space up to put the NVMe in the middle of the 2 banks of 4. They've actually improved the RAS features and usability features, and of course they're now based on the PCIe Gen 4, and these cassettes actually have electronics inside the cassette, so that had to actually change for the POWER9 machine. So I'm glad they're slightly different. We shouldn't be just moving an adapter between a POWER8 and a POWER9. It won't actually fit in the box. Okay, here's the chart I was expecting, showing you all the bits, and here you can see there's 4 in here for the first CPU, second CPU, third CPU, fourth CPU, the connectors that go between the connects. Oh, here's a little look in at the bay that has the NVMe U2 style slots in here, and yeah, press the blue button, pull the handle down, it pops it out a centimeter or so, and you just slightly tug it because they've got springs in here to pull it out to keep it there. There's a picture of it. This is the bracket that goes at the back for the cable management arm, very much like the E980. The E950 has one of these, but they don't have screws in here. They just sort of slot together, which means it's all a bit wobbly until you got it screwed in. Here's a look at the front of the machine. Looks pretty much like a Power 8 machine. There's probably subtle differences for reliability, probably uprating fans and things like that. We took a fan out, pretty impressive piece of technology. It actually has two fans. You can see that this is the back of the front fan, and here's the second fan. One spins in one direction and one spins in the other direction, so you actually get a non-spinning flow of air coming out the back of the fan unit. And you can replace those on the fly, and the other fans will pick up speed as if one fan fails. Here's the left and right. You can see this is early ship machine. We didn't get our serial number and MTM machine type model sticker in here. Looking at the top, most of these machines go in and work for 5 years and then get upgraded. So not a lot of people actually see in here. Press the blue button, lift it up, pull the lid up, and there we go. We've seen a couple of these pictures before. It all looks like very, very thorough engineering. Quite impressive, to be honest. You can see there's some more of the blue handles in here, all the voltage regulator modules, and we can see some in here. Big fans on the big heat sinks on these ones, probably running the power for the actual processors. Here's the top down. We saw that one before. Fans under the front and adapter slots at the back, and underneath the middle in here is the NVMe. Here's a little view down the side. We've actually got more VRMs in here than the Power 8 machines. Give you a little bit more headroom in here, and these are the light path diagnostic control features in here. Here's me comparing it with a Power 8. Yeah, there's 12 VRMs in here. We've got 15 in here, but otherwise same basic layout. I realized how fuzzy my Power 8 pictures were. Again, here's a little angled look down. You can see the great big block of copper that's actually sitting on top of the processor. Helps draw the heat out of the processor itself. Front view, looking down on the top of the adapter slots. Here's the memory. I think there was a picture of this in the slide deck. I'll just carry on because we're getting short on time. Yeah, here's us putting it on the rails. This is Mike Pearson with his improvised lifting device. It was quite heavy. We wanted to, this is 2 Power 7 machines that we're going to have crushed. So he's using that to get it the right height so we can lift it on. 4 people lifted it on. 2 people checked that we got it right. I think the next one shows you a diagram in here. CEs knew exactly what to do from the Power 8 experience. Get that nail head that's closest to the rack in first, and then you lower the front down. The IBM lifting device has a tilting table on it to let you do this quite safely. So here it is on the rail. It's quite heavy. You can see a little bit of a bend in the rail in here, so we slide it in fairly quickly. Here it is sitting above the system control unit, looking all nice and shiny and new. The CEs quickly put all the screws, the bolts in rather, just in case. We like to play it safe. They don't want the first big earthquake in London in 10,000 years to let the machine slide out on its rail, so that's safety. There it is with the covers on the top, or bezels as we call them, all looking very nice, ready to go. But we have some stuff to do around the back. Oh, here's our rack, Power 8 rack, a Power 9 rack. E980 is right next to it, and we're going to have to find another rack soon for Power 10 testing in a couple of years' time. Right, so what's the connectors in here? These little ones that have the little white surround, and I'm quite sure what's going on. I think this is to stop the bending of the cable at acute angles. They are used for electrical power to the system control unit below, which is sitting at this sort of level. We've got HMC cables running here. These are the Ethernet cables to the HMCs. We've got a USB connector, comes out of the first CAC. This cable just plugs into the back. You can't quite see it. Plugs in about here. And then we got the node, we call it the FSB cables already. All right. I tried to show the point-to-point in here. Some of them you can't quite see because of the cables are in the way. Now, very easy to install, but we didn't really cheat, just that we only have one node, so there's no node-to-node cables in here. And we've already seen this chart. You have to plug them in. Now, these are intelligent cables, and we really want to make sure people plug in the right ones into the right sockets. So as you go, Oh, didn't have it there. I thought there was a picture in here. It will, when you're putting in the cables, it will flash the two connectors that it wants you to put in between the two nodes and how long the cable should be. And then when you plug the cables in, it will do a quick check, make sure it's okay, and then it will suddenly start flashing the next pair of cables, or sockets you want to connect with the cable. So it's all quite nicely driven to get you to do the right cables in the right place. And if you do it wrong, it'll start flashing red LEDs, I presume, at you. This is more sort of a plumbing in here above the cable bracket. In here, you pull out these blue knobs and it can raise an inch. That lifts these up higher, so it allows you to get the adapters out easier. And you can lower it again because the machine above might have an adapter you want to pull out and it would be in the way. And the idea is that the cables are connected to the underside of the bracket, otherwise it will interfere with the machine above if you've got one. Okay, oh, here's me reminding you a few things. Follow the manual. But if you're familiar with the 880, it's pretty simple. No clock cables, so that's a lot simpler. I've talked about the flashing LEDs as it does that. And okay, it's just regular good things to remember. HMCs have to be the right level. Prepare everything in advance, site surveys and things. It's not a client install. It's pretty heavy, so you use that lifting tool. Don't want to make mistakes and end up with one dropped on the floor. I don't know whose insurance will cover that. It's a high-end server, so do it right first time. Read the flaming manual. And if you've got lots of them in a computer room, you need ear protectors, particularly when they start up. So we quickly went for quads VIO servers on our machines, running different levels of the VIO server. The bad news for us is it's a 3-month loaner. So it has to go back. It's a bit of a shame. But we've certainly enjoyed it, and we're going to take a lot more pictures of it as we decommission it. Hopefully it'll be useful for people writing documentation and things like that. A couple of little quirks in here. It powered it up, but look at that horrible picture. It looks like a 4U unit, just like the S924. So we complained, and the HMC guys, they promised they're going to fix the pictures for us. If they don't, when you get these machines, raise a PMR. There's nothing like a PMR to get the developer's attention and get especially little things, which is easy to do. We use colors, and we decided brick for this particular machine. Yeah, very early on we had the service processor problem because they were accidentally at different versions. So once we got that working, it's no longer performed like a brick. So that's where the color came from. Yeah, that's typical things you get with early support, beta testing. So ever since then, it's worked absolutely perfectly, which is good news. We had a fairly small configuration, 32 CPUs installed, and half a terabyte of memory. That's quite a lot of memory. And this is the HMC, so that's the same details. You can see it reserved 10 gig in here for the hypervisor buffering for high-speed adapters and things like that. Here's the PCIe Gen 4 slots in here with assigned to the various VIO servers. This is before we started VIO server 3 and 4, and the NVMe devices appear on the same list of adapter slots because it's actually coming out of a PCIe slot. And down the bottom we have a bit of USB key. Now you get the two, the first KEC, one of those it joins to the system control unit, and there's two others, and they all will be connected to this one thing in the first KEC. Okay, I was asking why is there an extra these C1s in here? That's confusing. Get rid of them. And the hardware engineer says, well, that's covering the electronics actually in the blind swap cassette. So they can actually report something wrong with the electronics in the cassette as well as something wrong with the actual adapter slots. Okay, so not a massive external change from the POWER8 machines. You'll be happy that I'm coming to a conclusion for 90 minutes. Hardware installed, no brainer. Follow the manual. No clock cables, that makes life easier. And we're expecting a large boost. There was nothing. We had a few shocks with the smaller machine. We didn't get that with the POWER8 machine. Same electricity, same size, and those sorts of things. And it shows us that they actually had fairly good confidence in this machine, because they lent it to us months before it's actually available. And after that, teething problems, it all worked fine. We really like this machine, up and down, and we've been hammering it as hard as we can, testing all sorts of things. NVMe, we've mentioned this. SSD, it's going to wear out. No, don't worry, we have this NVMe command, and here's the output from it. If you use the lsdev command, you can actually find out how many you got. We've got 1 in this case. Normally 2 would be good for a VIOS server. And in here, percentage of the lifetime used, 0. It's been running for 3 months, and we've used 0% of its lifetime. So we're not hammering it half as much as we think we are. And it's telling you all sorts of interesting things in here. You can see it's coming in at 800, or just under 800 million bytes. No, 800 billion bytes. Okay, carrying on. Oh, we can want to set, you go to ASME, if you go to System Config, Power Management, Power and Performance mode, you can actually see that we're in the maximum performance mode. That's how we get the high gigahertz rating. That should be the default, but there you know how to get that. We saw this information below down here as before. We tested with NMON. That's the first test we always run, and I can say that the machine is NMON approved. If you get the PowerPoint presentations from the AirExpert blog, then you'll have these great big detailed pictures in slides. You can use that for any purpose that you feel, quite high resolution. They actually call these the low resolution. The high resolutions coming in like 30 megabytes each, so we can't share those really. They're just too large. I like these exploding diagrams that I have down here as well. Oh, here it is. This is what happens if you set an explosion inside the box. Here's the crew that is doing this. I'm on the right. Gareth is on the left, and Mike Pearson's in the middle. So we're the ASC team in IBM South Bank, London, UK. As we said before, we're going to give you the PDS in the next hour or so, and the replays in a couple of hours go to the PowerVG, tiny URL PowerVG. And if you want the PowerPoint, I'm going to have to do a sanity check of the PowerPoint. I did the big check I did for the all those adapter lists and things. They're all in eConfig, so I'm happy to share those. And the actual PowerPoint will be on the AirExpert blog, like here. And with that, I think I'm done, Jyoti.
Wow, thank you very much, Nigel. Another marathon run through the material, but a lot of information there, so thanks again. We will be taking questions, but after I've stopped the recording, so please stay on and we'll handle the questions. Let me just conclude the main part of this webinar, so thanks for joining, and I'll stop the recording there.